Okay. Hi students, happy Holi to all of you. I hope you are enjoying this festival of colors. And today we are going to look at your topic of gravitation. So excited everyone? So fine, we will get started. So here I have got Abhay and I have Divyansh. So awesome guys. Fine. So here let me just begin with the initial important things. The ones who are watching me live for the first time on the Unacademy platform, that is the JEE English channel. So my name is Sumit Kundu and I am a BTech graduate from IIT Bombay. In the year 2003, I actually cleared my IIT JEE and I secured a rank of 2125, which gave me the branch of civil engineering. And after that, there's been a long journey after graduating from IIT Bombay. And initially, I started off my career as a software engineer. I gave it up within a span of 1 year, and then I started my own company in Bombay. It was into the field of recruitment. All right, so we had developed a platform, all right, which was an interactive platform between the employees and the employers, which was later acquired by Naukri.com in the year 2011. And since then, I have been training, teaching, mentoring, guiding students, all right, for their dreams, that is either IIT or whether it is to go to the AIMS or let's say the National Institutes of Technology. So students, it's been a long journey and I hope our interaction would be definitely fruitful for you students. Now, important thing is, like last year, over the span of the entire year, all right, whatever lectures were there for 11th and 12th standard, okay, all these lectures are actually present at your tinyurl.com/JEE mobile. So you can just go on to this particular URL and have a view at all the lectures. If you are preparing from the scratch, if you want to do it like a last minute study, everything is present. Everything. Okay. So you don't need to worry at all. All you need to go is to this particular URL and get it for free. Remember it. Everything is for free out here. All right. So all these lectures are basically available to you for free. All right. But on the Unacademy platform, we have the Plus subscription. Okay. Now the Plus subscription is something that definitely you guys should be looking forward to. And if you haven't taken the subscription as yet, okay. So students, go for the subscription and remember right now special discount offers are going on. Generally for 2 years it comes to 36,000, but right now it is at 32,400. 32,400. On top of that, if you're using this code SMLIVE, all right, if you're using this code, another 10% discount. Okay, so overall you will be ending up paying how much? Only 27,000. All right, so that's it. And let's see who all are there in the session. I see Moin, I see Rocky, Abhay, Sujal, Manthan. Good evening to all you students. All right, so students, in today's session, let me give you a small brief first. Okay, a small brief of what we are going to do in our today's session of gravitation. Okay, how important is gravitation for your JEE mains? And fine, advanced, we will look at it sometime in the future. But very importantly, that we would want to know how important is the topic of gravitation for your JEE mains. All right, now one thing is for sure that JEE mains, this topic gravitation is very scoring. Okay, so if you're looking for some quick marks in the JEE mains examination, this topic is definitely a must do. All right, second important point, why should I study this particular topic? Okay, now importantly, students who are watching it, who are currently in 11th standard and then they are going to the 12th standard, you must have already done your gravitation. Okay, this could be a quick revision for you for the entire gravitation chapter. Besides that, what happens is you've got two chapters. One is your electrostatics and the other one is your gravitations, which are like mirror images to each other. They are like similar. not congruent, but they are like similar. Okay, so whatever you have formulas for gravitational field due to a ring or due to a straight rod or things like that, they are the same. Whatever you have studied in gravitation, it is going to be there for electrostatics. So it's going to be kind of a revision for all you students. Okay, that way you can master like 2 chapters. Okay, that is like ek tir se do nishan. All right, well, I didn't know the proverb in English, so I used the Hindi one. Whatever. Chalo. Now we will start off with a warm-up question. What is a warm-up question? Before you go to a gym, you do some warm-up, right? So we will start off with some warm-up question, some easy question, and then we will try to look at some calculation-based questions as well. Okay. So all excited? Should we get started out here? Fine. Okay. Let's go for our first question. Very simple question. Okay, the understanding should be very clear. Okay, I had two objects. They were having a mass of m. They were having a mass of how much? M. So let's say this is m and this is m, and the force between them was F. The force between them was how much? F. Now what you did? You took both these masses and you put it inside a liquid. Okay, which had a specific gravity of 3. So how much would be the force between these two masses right now? So let's see how many of you can attempt this particular question. Let's see the responses coming from your end. Okay, yes, very good. Okay, awesome, fine enough. So remember one thing, if these were 2 charges and I put it into water, or let's say I put it into some other, like, I put a glass in between them, okay, then force between the charges get affected. But gravitational force is independent of the medium in between the 2 masses. So whether you put it in water or kerosene or petrol or any other liquid or any other medium is present in between them, or even vacuum is there, all right, the forces actually doesn't depend. It doesn't depend at all on the surrounding medium. So the force will continue to remain as equal to F. So option A is the correct answer. Very simple warm-up question that we had. Okay, awesome. Sujal, Nitish, Anurag, and I also have Priyansh. Very good students. Okay, so let's move ahead to our next question. So what do we have in our next question? Now this is a little calculation oriented, or I wouldn't say it's tough. Okay, now let's look at this question. All of you are ready? Okay, what do we have here? We have got a sphere. Okay, we have got a sphere here, and we have got a ring. So there's a ring on top of it. So try and understand, there's a ring on top and there's a sphere right on the bottom of the ring. Okay, they are asking us what is the force of interaction between the ring and the sphere, Now we know for simple that if I have got 2 point masses, it is very easy to find out the force of gravity between these 2 point masses. But when it comes to 2 continuous bodies, alright, then there might be a little challenge. Okay, but it is not so tough. Alright, why? Because I have got a sphere. Now what is the interesting thing about the sphere? Alright, what is the interesting thing about the sphere? Some of you have already answered, I can see. Madhvi Reddy, your answer is absolutely correct. Okay, good job. Now, what is the interesting thing about sphere is that I can consider it like a point mass. Okay, so now the interaction is between a continuous body and a point mass. That is also very simple. Okay, because all you need to do is find out the field due to this ring at this particular point, and you multiply it with the mass of the sphere, you will get your answer. There are actually 2 ways. There are 2 ways to do this question. Okay, now what is the other way? The other way is a little more challenging. Okay, but it is easy. Okay, what is it? You can consider the point mass to be here. Okay, and then find out the force, like you take small elements on the ring, say it has a mass of dm, and you find out the force between the mass of this sphere, and this dm, and you integrate it over the entire ring. Okay, 2 ways, but I find which way is easier. Find out the gravitational field due to the ring at this point and multiply it by the mass. You don't even need to use the concept of integration then. Okay, so how do we do it? Very simple. Let's go to the solution right now. Like Madhavi and other people, yes, Rishi, no, Ashwini, that's not the correct answer. D is not the correct answer. Sandeep, Anudeep, that's right. C is the correct answer. Okay, so what is the formula? Now, this is the reason why I tell you people that remembering certain formulas will really help you in the examinations. Okay, we do not want to go there in the examination and start deriving things. Okay, so that will be a really wastage of time. So all these formulas should be there on your fingertips. Clear? So what is the formula of your gravitational field? Gravitational field. Okay, so I'll keep it as your E only, gravitational field. Okay, due to the ring at this point, the general formula is G capital M. So I'll assume it has a mass of capital M. Okay, G capital M into X divided by X square plus R square to the power 3 by 2. So this is the general formula. Okay, general formula of the gravitational field due to a ring. Like, you know, you take a ring out here and then you want to find out the field at this particular point. This has got a radius of R. Okay, and this distance from here is X. So you want to find out what is the field out here. Okay, now what is X? X is given to me, root 3R. Root 3R is the distance between the center of the ring to this particular point. So I'll put down the formula here, will be G capital M into root 3R. Okay, by the way, there's a slight mistake here, so we'll quickly correct it. So this will be equal to root 3R divided by X square. X is root 3R only, so it will become 3 times R square. All right, plus R square. R is what? This radius, small r. Fine enough, clear, very simple. So this will be R square. Now this will be to the power 3 by 2. If you solve it, you will get Gm root 3, I'll take it here, into small r divided by, now try and understand, 3R square plus R square will be 4R square. Simple. So you just take the root of it, 2R, cube of it, 8R cube. 8R cube, 1R cancels one of the R in the denominator. So we have root 3 G capital M divided by 8 times small r square, and let's say this has got a mass of small m. So what did we find out here? We found out the field. We need to find out the force of interaction between the ring and the sphere. Alright, so what you do is you just multiply it with the small m and you get option C as the correct answer. Did everybody understand this? Okay, awesome. Everybody is convinced. It's option C. Now students, what happens is the question would become very challenging. Very challenging if instead of this sphere, we had, let's say, a rod. We had a rod. Okay, and let's say it had a mass m, then different points on this rod would be having a different value of the gravitational field. Okay, different value of the gravitational field. That means you had to only do it by the method of integration. All right, there was no other way. You could not use a formula in that particular case. So hopefully for JEE mains you will not have such complicated ones. You can be rest assured that you can be using a formula and get things done. Fine. So anyways, we will just clear off this part, okay, because we don't want it to be in part of your PDF notes. Fine. So excited students, let's go on to the next question. Let me see. Okay, chalo, next question. Next question is very interesting. Okay. There's a story behind it. What is the story behind it? I'll tell you. You've got Mars, okay, and you've got Earth. Now there was a person who was actually coming from Mars, all right, to Earth. From Mars to Earth. Clear? So he was traveling from Mars to Earth, and here in this graph, if you can see here in this graph, they have plotted his weight. His weight, as in his weight will be the net force acted upon by Earth and Mars, right? So his weight is being plotted against time. So which one of these curves, A, B, C, D, will be the correct answer? Alright, so I want you people to think about it, at least for next 30 seconds. For 30 seconds, just think about it, that if a person is traveling from Mars to Earth, let me draw it for you, that's better, isn't it? So let's say this is like Mars, well, let me take this. So let's say this is my Mars and this is Earth, alright. So a person is traveling, okay, at different points he is present, okay. Now his net weight is combination of the forces due to Mars and Earth, right? So they are asking us which one of these graphs will correctly represent it. Now I have already seen the answers coming. Rishi, Sujal, Anudeep, no, option A is not the right answer. Shalini, yes, that's a correct answer. Rishi Joshi, that's a correct answer. Yes, option C is the correct answer. Do you know why? Very simple. Okay, that in the journey from Mars to Earth, there will be some one point, right? There will be just one point maybe, wherein the net force due to the Earth and the Mars will balance each other. They are like, you know, they are attracting the boy, right? The man, the astronaut, whoever is traveling from there to here. So both are pulling him, right? So there will be one point in between Mars and Earth where both the forces are going to balance each other. So his weight will be equal to what? 0 at that particular instant. So among these A, B, C, D, it's only option C that I can see will be giving the value of the weight equals to 0 only once. Option D is giving me the value of his weight 2 times. Why will it be so? It cannot be possible. So very clearly identified, option C is the correct answer. Students, this was an Olympiad question. Alright, well, very simple, but anyways, it was logical, and all of you, most of you, I can see, have cracked this question. So that's superb, okay. Chalo, want to do more such questions, in today's session. I hope you are enjoying the session. If you're enjoying the session, you know what to do. Come on, increase the like counter, make it go up to 50 by the end of the session, make it go up to 50. Alright, not by the end of the session, rather let's say in the next 20 minutes. In the next 20 minutes, it should go up to 50. Right now, it is at 22. Okay, students, more such questions right in front of you. This one. Questions that actually can make you think for a little bit. Okay, what do we have here? I have got 2 spheres. You can see them very clear. Okay. Both are having a radius of r. And they're touching, they're metal spheres, they're touching each other, okay. They're asking us that the force of interaction between these 2 metal spheres will be proportional to which root of r, okay. Now, when we generally see this kind of a question, the first thought that comes to our mind is this. But here, it is going to fetch you minus negative marks. Okay, this is going to fetch you negative marks. Obviously, it cannot be. I mean, if it is such an obvious question, why would it actually come? Right. So, we need to find out exactly that the force is proportional to what? Okay, try and understand this. Force between 2 spheres is G. Now, these are what? Identical spheres. You can see them. Alright. So, if this has a mass M, this will also have a mass M. Right? This is a mass M, this also has a mass M. Clear? So force between them will be Gm square. Now what is it? In sphere we can consider as point masses. Remember that, students. We did that question of a ring and a sphere. So sphere I could actually consider it as a point mass. That's the same logic I'm going to use here. Okay. So you see here, I can say that all the mass is located at its center. Here. So what is the distance between these 2 bodies? 2r. Okay, very simple. So 2r whole square. So I can write this as Gm square upon 4r square. Alright. But here also you can see that it's inversely proportional to r square. But what about the mass of these bodies? They are identical. So let's say they have a density rho, this will also have a density rho. Okay, so I can say mass will be equal to 4 divided by 3 pi r cube into density, right? Is this clear? Now see the difference out here. So this can be written as g upon 4 r square, and m square can be written as 4 divided by 3 pi r to the power 6. This will be all squaring up, r to the power 6 density whole square. So you can see rest everything here, g 4 by 3 pi 4 density, these are all constants, right? So this clearly tells me that r square will go away, so minus 2. So force will be proportional to r to the power 4. Maza aaya, students? Did you enjoy this question? Doesn't appear to be very obvious. So option B is the correct answer. Let me see who all have got it correct. Rishi Joshi, Sujal Gupta, you guys have got it correct. Awesome guys, awesome. Chalo, if you've liked this question, you know what to do. Press the like button. Do not forget to share. Spread it as much as possible across the country. Spread it as much as possible over your WhatsApp groups, okay, over your Facebook, over your other Telegram groups and things like that. Okay, let everyone know that there is such an awesome session going on in gravitation. Okay, students, I'm sure you're going to enjoy the next question. Something to think about. All right, not a direct giveaway question to all of you. So what do we have here? Now this one is easy. This one is not the one I was talking to you about. Okay, by the way, we can calculate what is there in this question. Let me put it across to you. We've got lots of masses here, infinite number of masses. Okay, I've got a mass here at x equals to 1. I've got a mass here at x equals to 2. I've got a mass here at x equals to 4. Okay, and I've got a mass here at x equals to 0. And infinite such masses till infinity. Okay, we need to find out the force on this particular block. Okay, now the force due to this one will be in this direction. The force due to this one will also be in this direction. The force due to this one will also be in this particular direction. Okay, so what will be F1? Let me say that this force is F1, this force is F2, this force is F3. I need to find out the net force. Let me see if some of you have already got me the answer out here. By the way, this option is a little bit of a problem here. It will be 3 by 4 gm square. Okay, 3 by 4 gm square. Okay, so that will give you what exactly? Let's see now. Does the option change? Or you still have the same option, whether it's B, whether it's C? Okay, let's see it. Fine. So what will be F1? F1 will be equal to simply g m square upon, how much is this distance? 1 square. What will be F2? G m square upon 2 square. What will be F3? G m square upon, what is this? This distance? 4. This distance is 4. So this is 4 square. Okay. If you add up all of these, now there are infinite such forces acting on it. If you add up all of them, your F net will be gm square will be common in all of them, and you will have 1 plus 1 by 4 plus 1 by 16 and so on till infinity. So what will be the net force? Let me change the color here. So the net force will be gm square. Now try to see this. This is a sum of a infinity. What? Geometric progression. Okay, infinite GP. All right, and what is the common factor here? 1 divided by 4. So what shall be the sum? 1 divided by 1 minus r, so 1 by 4. So this will be equal to 4 divided by 3 gm square as the answer. Okay, so the correct answer will be 4 divided by 3 gm square. Option C will be the correct answer. Let's see on the screen how many of you have got it correct. Okay, Abhay, no, that's not the right answer. Rishi, you are correct. Anudeep, rocking as usual. Shalini, you're doing good. Okay, chalo, let's go ahead to the next question. We want to cover as many questions as possible so that maximum benefit will go to you students. So this is the question I was talking about. All right. Now it's a multiple choice question. It's a multiple choice question. Okay. There are two options correct. There are two options which are correct. Okay. One is about the field, other one is about the potential. All right. So they are saying that there is a spherical shell. Remember, it's a shell. All right. It's a shell, and it is cut along a chord. So this is a chord. You see here. This is a chord. It's not the diameter. Diameter is also a chord, but we do not want to consider the diameter. Diameter is the longest chord, right? But it is a chord just on the top, right? Now there are 2 points, point P and point Q. Point P and point Q. Now here, we want to find out the relation between the field at point P and point Q. So we'll go to the first option. The gravitational field at point P and Q, are they zero? The first point. Okay. Can we just interact quickly over the chat? Can we just interact quickly over the chat? Will the gravitational field at point P and Q be equal to 0? Well, no, it cannot be. All right. Very well said. Very well said. Some of you have already given me the answers. I said there are two options which are correct. There are two options which are correct. All right, not just option B, but besides option B, there is another one also which is correct. Okay, by the way, first we will try to look at the field. All right, now in the first sense, P and Q are points just very close to the upper portion and to the below portion. Okay, now they are just almost coinciding with each other. If you look at it, they are almost like coinciding with each other. So at that given point, the field is 0. All right, but it is the net field. All right, it is the net field due to the upper portion and due to the lower portion. Try and understand this. Okay, it is due to the upper portion and due to the lower portion. So there exactly you would see that due to the lower portion, the field would have been in this direction, and due to the upper portion, the field, let's say, was in this particular direction. Then overall field at that point will be equal to 0. So the sum of the gravitational field at point P and Q is 0. This is the correct answer. I hope everybody's got that. Option B, yes, and option D, yes. The gravitational potentials at P and Q are unequal. Why exactly? See, potential is a scalar quantity. Potential is a scalar quantity. So potential at point P is due to all the upper masses. Potential at point Q is due to all the lower masses. All right. So we can see the upper mass is less as compared to the lower mass. So the potentials are what? Unequal at points P and Q. I hope everybody has got it. These kind of questions are usually there for reasoning and assertions, or let's say multiple choice questions for your advanced paper. By the way, I hope everybody has enjoyed this, and now let's move on to the next question. Okay, as many we can finish in this next how much time's left? 15 minutes. In the next 15 minutes. All right. So we need to find out in this, we have got two concentric shells. We have got what? Two concentric shells. Mass 1 and mass 2. Okay. There are 4 points which are given to me. 4 points. A, B, C and D. Okay, now come on quickly students, let's have a look at the solution to this. Where will, if I put a mass M, where will the net force be equal to 0? At D, C, B or A? All right, let me repeat the question to you once again. It's a very simple question. Okay, A, B, C, D are 4 points. Where exactly, if I put a mass capital small m, let's say, where the net force on that mass will be equal to what? 0. All right. So how do we go about it? So how do we go about it? Well, at B, some of you are saying at B. At D, well, Yash, I think yes, Yash, you are correct. Option D is the correct answer. Okay. Understand, very simple concept, the same as before. That inside a concentric shell, field is actually equal to 0. All right. So if I consider A, there will be field due to the outer sphere and also due to the inner sphere. All right. Same thing with B. At C, the field due to the outer sphere will be 0, but due to the inner sphere, there will be some field. So if you put another mass, it is going to experience a force. Very simple enough. What about point D? Point D will not have any field at all. It is inside both these concentric shells. So if you place a mass m here, it is not going to experience any force because the field here is actually equal to 0. Okay, fine students, that's the end. So here option D would be the correct answer. Fine, let's move ahead to the next question. I hope all of you are enjoying all of these questions. Quick revision, isn't it? Quick revision before the JEE. Now, here I'm going to teach you a short trick. Alright, and if you like this short trick, alright, do not forget to press the like, share and subscribe. Okay. So what is the question telling me? It's saying that we have our Earth, our beautiful planet Earth, we can see here. Now, this mass which I have dragged it to a height of 3r was initially present on the surface. Alright, was initially present on the surface of the Earth, and then you increase the height by 3r. Clear? You increase the height by 3r. So what will be the change in potential energy? Now I know this question is very simple. As such also it is very simple, but here I'm going to teach you a short trick which will help you in your future questions. I'll tell you how. Alright. Now we know, let's say that this point here is A and this point here is B. So change in potential energy can be written as final potential energy minus initial potential energy. We know how to do it, right? We know the formula of whatever is the potential energy. It will be minus G capital M into small m. Capital M is the mass of the Earth. So capital M is the mass of the Earth. Alright, and small m is the mass that we have shown out there. What is the distance? Final distance at point B between the center of the Earth and this, the total distance is how much? 3r plus r. So that will be equal to how much? 4r. So this is 4r minus UA. What is the potential at point A? What is the potential at point A? Very simple. Okay, when this ball was at this surface out here, it would be minus G capital M small m upon r, right? If you happen to solve this, you will get G capital M small m upon r common, 1 minus 1 by 4. So this will be equal to 3 divided by 4. G capital M, I need to change the color here, G capital M small m upon capital R. Okay, now we have to express the answer in terms of mgr. Alright, what you do is you multiply this by square and another r out here. So you multiply numerator and the denominator by r. Gm upon r square is nothing but equals to acceleration due to gravity. So this will become equal to nothing but 3 by 4 mgr. That's the answer. Alright, now I told you that I'm going to give you a single formula to find it out. Okay, I'll give you a single formula to find it out. How do you do it exactly? Let me tell you. Okay, see, this was not a very difficult question. For sure, everybody knows the formula of potential energy, so they can find out the difference in the potential energy and they'll get the answer. Okay, but how do you do it, like, you know, very quickly, Alright, let's say in 10 seconds you want to do it. Alright, so remember this formula here, delta U will be equals to mgr into n divided by n plus 1. That's the formula. If you have to use it, you can use it and get it within 10 seconds. You don't have to use any calculation whatsoever. Alright, so this is really going to ease up the entire thing. Alright, how exactly? Now what is the value of n out here? See, if it is taken to a height of h equals to nr, if it is taken to a height of h equals to nr from the surface of the Earth. So initially it was at a height on the surface of the Earth, and then it was taken to a height of what? How much? 3r. H was equals to 3r. So the value of n becomes equal to what? 3. So you right away put it 3 divided by 4 mgr as the answer. 10 seconds you get your answer. Alright. Now, will these kind of questions come in the JEE? No, they might not come. But something which will use this data, which will use this calculation to calculate something further may be there in the JEE exam. Like a question, let me see it right now. Like this question. Okay, this is also a simple one. Guys, stop spamming. Okay, chalo, let's see this question. there is a body which is taken to a height. Let me explain to you the question. There was Earth, Mother Earth, right here in front of you. Very beautiful circle that I have drawn here. Okay, you must all appreciate this. Now on the surface of Earth, there was a body. Clear? Now it was projected with a velocity v, and it reached up to a height h equals to capital R. Okay, calculate it by finding out the potential energy between them. All right, and then whatever is the change in potential energy will be equal to the change in the kinetic energy and all of those things. Then probably it is going to take a lot of time, right? But if you know that previous formula, that the change in potential energy is going to be how much, we know very simply delta U will be equals to mgr into n divided by n plus 1. Simple enough. So you put down the values mgr. Now what was n? It is taken to a height of h equals to r. So value of n is equal to 1. Simple enough, right? So what do you do here? 1 divided by 1 plus 1. So change will be mgr divided by 2. Very simple. Now whatever is the change in the potential energy will be also be equal to the change in the kinetic energy, right? So at this point, if you see point A and point B, so here it had potential UA plus KA. Here it will, just a second. Okay, here it will be equal to UB plus KB. So you can easily find it out. Okay, whatever is the change is equals to mgr by 2. So mgr divided by 2 will be equals to half mv square. So m and m is going to cancel, 2 and 2 is going to cancel. That means the velocity will be equals to root over gr. Okay, now here value of g is what? It is not expressed in terms of G and R. It is expressed in terms of capital G and M and all that. Okay. We know value of G is what? Gm upon R square. Gm upon R square. So this will be equal to root over Gm upon R. This is option A. That is the correct answer. So what are you going to do? You're going to save time. You're going to save time if you know this particular formula out here. Alright, so let's see how many of you students have done it correctly. I can see Anudeep, very good, awesome. Yash, you have done it correctly. Karthik has done it correctly. Awesome guys, chalo, get ready for the next question. What do we have here in the next question? Simple enough. What I'll do is I'll give this question to you as a homework. This is a very simple question. Okay, let's just skip this question. Okay, what do you say? Homework. We had in this question what we had was very simple. On the surface of the earth, they took the time period t, right? That was your t1. Then they took the pendulum, the simple pendulum, to a height h equals to capital R. All right, and then they found out whatever is the time period that was equal to t2. And they asked us to find out the ratio of T2 by T1. Fine enough. Now, time period we know is 2 pi root over L by G effective. So, when you take it to a height of H equals to R, the G effective value is going to change, right? G effective value is going to change. So, you're just going to insert the value of your G effective out there and get your answer. The answer should come out to option D. So it's not a very difficult question, but if you want me, let me look at the chat box. If you want me to do this question right here, right now, should we do it? Okay, chalo, let's do it. Okay, because some of you just gave me a wrong answer out here. Okay, Rishi, that's not the correct answer. The correct answer is option D. It's not option B. Okay, let me see how exactly. See, G is given as your Gm upon R square. Very simple. G dash will be Gm upon 2R whole square. That will be Gm upon R square into 4. So T2 by T1 will be, now the length of the simple pendulum is going to remain the same, right? So this will be equal to root of G upon G dash, right? So what is G? G is G, G dash is G by 4. So G by 4, G will cancel. This will be equal to B, option D. Fine. Chalo, no problem with this particular question also. All right, very simple it was. Homework became classwork. Fine. Now here, now these are some of the questions which are required to be done by using the concept of your derivative. That will be like, really easing up the entire process. Fine enough. So let us just see what do we have here. So the earth was there and we shrunk it. We shrunk the entire earth. So what will be the change in acceleration due to gravity? What will be the change in acceleration due to gravity if I decrease the radius of the earth by 1%? I decrease the radius of the earth by 1%. Okay. See, try and understand. If the radius of the earth is decreased by 1%, the acceleration due to gravity will increase or decrease. See, mass I am keeping the same. Mass I am keeping the same. But the radius is decreased and acceleration due to gravity is inversely proportional to r square. So, if r is decreasing, g should actually increase. Right? G should actually increase. So you shrunk it by 1%. So the value of G should actually increase. So here, whichever the options are, decreases by 1% and 2% will automatically go away. Very simple, right? So now you have a 50-50 question. 50-50 question. 1% to dekho ho nahi sakta because it is inversely proportional to r square. So there only you get a clear indication it is going to be option D. Okay. But let's try to do it. Let's try to solve it. All right, let's try to solve it. A lot of you have given me the correct answer. Okay, let me do the problem. Anudeep Reddy is telling me, sir, please kar do is question ko. Let's solve it. Okay, so what is G? G is equals to Gm upon r square. Very good. We all know this particular formula, right? We know this formula. Now what you do is you take the derivative on both sides of the equation. Okay, take the derivative on both sides of the equation, right? Differentiate both sides of the equation. That's what I try to mean. So you will get dg will be gm is a constant, right? And this is r to the power minus 2. R to the power minus 2. So you will write minus 2 here. G to the power minus, excuse me, not g. It is going to be what? R. Very nice. It is going to be r to the power minus 3 into dr. Very simple. I hope this part is visible. This part is visible. R to the power minus 3 dr. Clear? So, I'm going to rewrite this. dg will be minus 2 gm upon r square into dr upon r. Because I have got what? R cube. Isn't it? So, r square into r. What is this value? Gm upon r square. It is equal to G. It is equal to what? G. So, what I can do here is dg upon G will be equals to minus 2 dr upon r. That means percentage change in G will be minus 2 times percentage change in r. So, we got the relation very, very clearly from this equation here. So what was the percentage change in R? Negative, because it has shrunk. So radius is decreased. So it is minus 1%. So minus 1% into 2 minus plus 2%. Minus will give me plus. So it will increase by option D. That is, it will increase by 2%. I hope everybody has got it right now. Which state are you from? Yash says Maharashtra. There is a very big, now he who Anudeep knows, CLG, it's SLG, it's Siliguri. Okay, so students, let's take up the next question. Now this is also a very simple question. Gravitation, full of simple concepts, all formula based. All right, there is just one concept, that is when you project, like let's say I've got a sphere here and I've got a ball here and I project this ball with a certain velocity, then what will be the closest distance of approach? Like these kind of questions could be a little challenging because here all the kinetic energy, now this is also not very challenging, this is also like very simple. All the kinetic energy will get converted into what? Potential energy of this bigger sphere and this body here. So wherever it stops, wherever all the kinetic energy has stopped and it has converted into the potential energy of the sphere and this body, That's how you find out the distance of closest approach. Now, there are some of these kind of questions which could be a little tricky, alright. But other than that, all are formula based, right? So, we see here, we have got a triangle, and at the vertices of the triangle, I have got a mass at C, I've got a mass at A, I've got a mass at B, alright. Now, what they want us to do is expand it. Now, the distance between the two spheres is A, so it's an equilateral triangle. I'll change it into another equilateral triangle of side distance 2A, 2A and 2A, right? So, what will be the work done? Now, why did I take up this question? Very importantly, see, finding the work done is not very difficult. Alright, but here you see that there is a positive, there is a negative. So, students, they generally tend to make up this kind of a small error. They don't take these very little things into account. So, that could be a problem for you in the examination. A certain doubt, okay, can actually make you lose 5 marks, because this is an easy concept, but you did not get it correctly. So, you lost that 4 plus that 1 negative marking. Okay, so I want to save you from all these things. Now, how do you do it? See, it's very simple. How do you do it? See, concept should be very clear. Work done should be change in potential energy. External work done should be equals to change in potential energy. If it was asked what would be the work done by the gravitational force, it will be minus delta U. So, this point should be very clear to the students, and finding delta U is not very difficult in the final setup. Now, they are moving far away from each other, so potential energy is going to increase. You can look at it that way also, okay. So, if they are moving far away from each other, the potential energy is going to increase out there, alright, because it's negative, right? Potential energy is minus G capital M small m upon whatever the distance here. Now, here the distance at UA will be equal to, try and understand, both are of same mass, all are of same mass. So, Gm square upon A into 3 times. UB, not UA, like say first setup. Let me change the notations, otherwise it will be confusing for you whenever you refer to the notes later, alright, and this let's say is 2. U1 is minus Gm square 3 times divided by A, and U2 will be minus Gm square into 3 divided by 2A. Alright, that's going to be the only difference. When you take the difference, you will get a positive value, and the answer will come out to 3 divided by 2 Gm square upon 2A. Alright, so only point to be highlighted is this. Remember this, very important. Okay. Good job students. Option B indeed is the correct answer. Chalo, let's have a look at the last question. The last question just talks about the conservation of angular momentum between 2 points A and B, alright. OA and OB has been given to me, okay. The ratio of OA and OB is equal to X. I need to find out what will be the ratio of the speed at B to that of A. Alright, that means VB by VA is what I need to find out. Very simple. Between points A and B, angular momentum at A will be angular momentum at B. What is the formula for angular momentum? MVA into A, that is OX, OA, sorry, that is OA, sorry for that. Just a second. Let me finish it up quick. So, this will be equal to what? VA. What is this distance OA? OA is OA. OA is OA is equal to M VB into OB. Clear? What has been given to me? OA by OB. M and M is going to cancel. They have asked me VB by VA. VB by VA will be equals to how much? OA by OB. What is OA by OB is equal to X? Very simple question, yeah. Option B is the correct answer. Only the revision of conservation of angular momentum is important out here. Alright. So students, that's the kind of end of today's session. Okay, the last question was only a repetition. So whenever you get the what do you call it? Whenever you get the PDF notes, just have a look at the PDF notes and Do these questions once again if you are looking at it for the first time. A lot of you students, like I see Rishi Joshi still here from the beginning of the session. He's been given me a lot of correct answer. Okay, and I can also see Karthik, yeah, good job. Acha guys, dekho, whatever you guys think about these sessions, please do write to us on the comment section. ठीक है? See, when you write to us on the comment section, it's not like, you know, we do not read it or we do not go through it. We definitely want to make sure that whatever you're writing on the comment section is taken very, very seriously. All right. So if there is any chapter that you would want to do in priority, if it is like, you know, I like, you know, some of you told me last time, like I read through every comment. I read through, like, you know, after going back home, that's my entire day's work. Okay, so I just try to review all of those things. So what I do is, like, you know, some students told me, sir, you are doing only 11th standard. Okay, so start simultaneously 12th standard also. But you know what? I wanted to finish up the entire mechanics at one go. My principle was very simple. When I've started mechanics, now today was the last session on mechanics. So mechanics is now over. Fine. So now I'm going to start off with your 12th standard syllabus also. That is right from electrostatics to your current electricity, AC currents. I'm going to go right through that. Okay. So there's going to be a lot of discussion on the 12th standard syllabus also. Simultaneously, I'm going to run optics first. And then I'm going to go to, let's say, your other topics like heat and thermodynamics, and then your waves. Okay, so waves, I'll try to keep it at the end, though it is again a very scoring topic for your JEE mains. All right, now important thing is that you write it on the comment section, and also you should interact with us through the Telegram app. Okay, those who have got, I think, like, you know, lots of you who are watching on a regular basis must have already downloaded, and if you haven't downloaded it as yet, okay, see, not just writing to us, do you know, I mean, I'll tell you something very interesting today. Okay, I'll tell you something very interesting. Thank you Shalini, thank you, God bless you, bacha. See, I'll tell you one thing very importantly, that why do you people go to IIT? Or why do people go to Harvard? Or why do people go to Stanford? Okay, see, definitely there is a quality, but you must have heard about this particular proverb, birds of feather flock together. All right, now what does it mean exactly? That when we go to IITs or we go to these universities like Harvard or Stanford, we get to meet people of the same type. And when the same kind of people, they come together, something really beautiful will only happen. All right, try and understand this. Okay, so when you join this particular group, see, try and understand what I'm trying to say here. When you join this group, you will see many of your kind of people will be there. So when you interact with them, when you have a doubt and you're posting it, and somebody else, all right, who knows the answer to the doubt is again, like, you know, reverting back to you. Such a wonderful platform. Okay, you don't have to go run after somebody to post a doubt and get your answer. So join the group, post your doubts out there. Somebody or the other is going to look at that particular question. Maybe it's not a teacher, but it could be your peers, it could be your friends, or whoever is present in that particular group. So you understand the importance of this, right? Now, next thing I told you in the beginning, tinyurl.com/JEEmobile, the archive of the entire video library or the video lectures of the last 1 year. Okay, go there, check out. PCM for 11th and 12th, all are present there. So just go ahead and explore it for yourself. I don't need to explain to you all these things. Okay, now what I need to explain to you is the Unacademy subscription. Students, if you're still thinking that should I take it, should I not take it, okay, what will happen, what will be the benefits, I'm already getting everything for free, so why should I come there? Okay, now try and understand. A live class is a live class. Okay, it is totally different. I mean, there are so many people, those who kind of take up these special classes at the Unacademy platform. Okay, so they know exactly like what is the difference that is being created at these live sessions. All right, so you get to interact with the educator, you get to have these interactive polls and the leather board. So learning becomes interesting. The entire process of learning becomes so very interesting that you feel like be attached to this platform for longer duration of time. I see in my session some of the students, those who actually come in the afternoon, they also join at the night time, all right, because they are preparing, they are like, droppers who have dropped class 12 standards. So they are like, most of the time they have all the time in their hand. Okay, so they are attending the morning sessions, they are attending the evening sessions. Okay, they are trying to take up quizzes, they are trying to do as many questions as possible. And right after they do the question, we have a poll, and after the poll, what do? We discuss that particular question right away. So if you're facing a doubt, if you're facing a difficulty in the concept, it gets discussed right then and there itself. All right, and you get to have a practice also. You get to know what are your strong areas and what are your weak areas. Are you getting what I'm trying to say? Okay, so next we have test analysis and series, test series and analysis. I think this is a self-explanatory point. I don't need to explain on this. You've got live doubt clearing sessions. Okay, so in these sessions, generally towards the end, okay, and there are some educators who declare that today I'm only going to do doubts. So post all your doubts, as many as you have, okay, and the educator just discusses your doubts. He doesn't teach anything on that particular day. Okay, so that kind of thing is also there, and you just need to take a photograph of your doubt, whatever, from whichever book, or you just snip it from your Kindle or whatever you have in the photograph format, and you just need to upload it. All right, so that's how you do it. And students, as I tell you, Unacademy is not just a platform, it's kind of a university, okay, where you get so many educators with just one subscription, and the price is like what? Peanuts if you look at. I'll tell you first how to get the subscription. Okay, see, you guys are smart enough, the new generation, the new age kids, all you need to do is Unacademy learning app. You just type it out here, install it, very simple, you know how to install it. Okay, and whatever is going to come up next, you just choose plus. All right, it is plus. Besides, like, the name has also got a significance. See, all that we are giving it to you for free. Now this is like a plus. All right, so for this plus, like, you choose IIT and then you click get subscription. Now for this plus, for 2 years, they are actually charging you how much? 32,400. Okay, that's like very less. All right, although general time it is 36,000 for 2 years. Okay, but right now there's a special season offer which is going on, examination season and all that, so they've given it to you at 32,400. On top of that, you use this code SMLIVE, you get another 10% discount. Okay, so then it becomes 27,000, and for 2 years. Okay, so everyone's got it. Important thing, those who are watching me live for the first time, and this JEE English has become super active from this year onwards. So in JEE English, once you get subscribed, see, first of all, like, share, pehle hi kar do. Okay, do it instantly, the like, share. All right, and after that, let me tell you, once you get subscribed, we are going to start with the daily lectures in from the month of April. Okay, like you had last year in the JEE channel, all the lectures in English. All right, and this is specifically for the entire nation, where Hindi is a challenge still. Okay, where people prefer to learn in English, right? So for all you students, those who prefer to study in English, this is the channel that you should be looking forward to, and it is one of its kind in the YouTube environment, who give you daily sessions in English, purely in English. All right, I'm stressing on that word English, you know why exactly. Okay, so subscribe and you wouldn't miss out on any of the special sessions. Do not forget to press on the bell icon so that you get notified, and importantly, you would be getting something very useful for your preparation. Okay, that is PDF notes. Now you're getting whatever PDF notes, they are like, a series of questions, right? But later down the line, when you have got like regular lectures happening over this channel, so you're getting the notes of the entire session with whatever the teacher is writing on the board, right? So I think that's something, free notes. Okay, people are selling notes, but these are all free. Okay, so students, all these, and remember that besides the JEE English channel, we have the NEET JEE Foundation. So whoever people that you know in your surrounding areas are either appearing for medical or JEE or foundation. Like JEE, they want to do it in Hindi. Okay, they are more comfortable in Hindi, so you can just suggest them this particular channel. Okay, and students, final thing but not the last thing, you want the 10% off, use the code SMLIVE. God bless you and see you tomorrow with fluid mechanics. Thank you. Bye bye.